Let's see what we're going to cover today. First, we will check what is the problem, and we will walk you through on how we saved the whole solution. Then, we will see what didn't work and how we improved the system to what we have right now. Afterwards, we will check how Movie Groovy works in action, and we will finish with the moments that saved the whole experience. Let's start. So, what's the connection between a pizza, a remote control, and a clock? Let me tell you a very quick story. Once a year, my brother Manolis and his wife Jenny come to visit me here in Athens. We are all massive movie lovers, and we have a sweet tradition. We always watch something while having dinner. So one night, we ordered pizzas. My other half, George, took care of the food. And my job was to find the perfect movie to watch. I took it very seriously. I opened all my streaming apps and started suggesting things. But things got complicated really fast. My brother had already seen almost everything. George only wanted something with action. And Jenny wanted something light, something cozy. 40 minutes later, I was still scrolling, staring at the screen. The pizzas were getting cold, and I was getting frustrated. And in the end, we just gave up. We rewatched Friends just so we could finally eat. Has this ever happened to you? Having this endless choice and still being unable to choose anything? Let's see why this happens.
Let's take a look at how algorithms decide what you watch. Take a leading streaming platform, you know, the one with the red fancy logo. It tracks everything, what you watch, when, on what devices, in what language. Then it scores through thousands of titles and tries to predict your next click. Your homepage is personalized and the system keeps learning from your behavior. But here is the problem. Next slide.
Sorry.
Everything, this is a chart where shows what is happening to us emotionally when we try to select something to watch. We start excited, curious, ready to find something good. But after endless scrolling and thousands of options, excitement drops. We feel overwhelmed, decision fatigue kicks in, and we just pick something to watch just to end the search. It's a relief, but it's not satisfying. And over time, watching becomes a habit, something we do passively, without joy.
That made us wonder, are the systems really designed for the user or for the engagement metrics? You have probably seen this pattern everywhere. In social media apps, shopping apps, music apps, the same loop appears over and over again. So when the problem hit, I thought there's going to be a better way. And as an engineer, I couldn't just complain. I had to fix it. So we discussed it with Eleni and George and said, let's do it. But as developers, it's easy to create something for the sake of innovation. Fortunately, we didn't want that. We want to build it for humans, because behind every interaction is a mood, a story, a moment. As Sebastian Ramirez, the creator of Fast API, once said, focusing on innovation is wrong. We had to be a power user first and try to solve a real problem. And that's exactly how we approached it.
So we started imagining a better way. What if recommendations match our mood, not our history? What if we are able to chat with our favorite platform and ask directly what we are in the mood for? And what if all our subscriptions are connected, working together to suggest the best choices for us? We had ideas, but we wanted validation. So we asked people, and we found out that 1 out of 3 have more than 1 subscriptions. 30% of our responders watch more than 3 movies or series per month. 50% of them usually struggle to find something new to watch, and it takes around 15 minutes to find something, even more if we are with friends and family. And now I have a question for you. Could you imagine what would someone recommend to a friend who is feeling sad? Nothing?
Don't be shy.
Okay.
Okay, I will answer it. What?
Something uplifting.
Yeah.
Yeah, exactly. Something positive. A comedy, for example. That's what most people responded to us.
So our hypothesis becomes simple. If we design a system where users can input their mood, then they will choose faster and feel more satisfied with their recommendation. Now let's move to the solution. To guide it, we have first to define our North Star, the principle that shaped every decision. In ancient Greek theater, the plot wasn't the measure of a play. Its value came from the catharsis, the emotional release at the end. So we asked, why should technology that recommends stories forget that? Our North Star became this: how people feel after they watch something. We designed everything around that. We transformed our data to reflect that choice, and we decided that the system should be really simple and easy. We have to hide the complexity behind the system and let the users just enjoy it. Here is how this philosophy became features. We started with the mood. Instead of asking people to search by title or specific genre, we asked them how do they want to feel, and we matched them with titles that fit this emotional vibe. Then we added streaming platform filter, so users only see options that can actually watch based on their subscriptions. We also added some optional filters like genre and media type for those moments where people want more control or feel like being surprised. And because this is an emotionally sensitive space, we designed everything to be privacy first. No login is required, and no data like moods or recommendations are ever stored. Each session is temporary, so users stay anonymous by design. Finally, we explain every recommendation with a short phrase like, "Why this?" so users understand the emotional reasoning behind what they see. These phrases connect the vibe with the recommendations and help users build trust with the system.
Behind every feature, we kept asking, does it help users feel understood? Does it give them control? Does it make the system transparent? Those questions became our 3 pillars: emotional understanding, control, and transparency. But features alone aren't enough. It's about how they flow together. In this diagram, we see the conceptual flow of Movie Groovy. Everything starts with the user. They share what they are in the mood for, let's say vibe, cozy, and chill in platforms Netflix and Disney+. Then the system takes over. It searches for appropriate suggestions that match the emotional tone and platform availability. Next, we enrich those suggestions with metadata like synopsis and duration. Then we add a short explanation why this movie fits the vibe. And finally, we get 10 recommendations that are not only resonate, but are emotional aligned. This flow, this loop, put together user input, AI reasoning, and explainability. in a simple way. For the user, it feels easy, but behind the scenes, it took a lot to make this happen. Let's see together how we built Movie Groovy.
Our first system architecture was designed for the development speed. We wanted to test the idea quickly, so we created an AI agent, a monolithic AI agent. This agent handled everything from start to finish. When a user submitted a vibe, the request will go through our fast API backend, and this backend then triggered a pedantic AI agent, which used a couple of Gemini models. This agent did it all. It understood the mood. It transformed it to an embedding. It searched for matching content and even generated the explanations. In the background, a MongoDB stored our movie metadata that we needed to enrich the results. And Qdrant, our vector database, handled the semantic similarity search. It compared the movie vector to the mood vectors. The front end was built in React and just displayed whatever the agent returned. The whole system was deployed in Google Cloud Run, which is an easy serverless option, perfect for a system with no real users yet. It worked, but we quickly hit limits. The main bottleneck was the AI agent itself. We gave it the autonomy to do a lot of things on its own without supervision, and while this autonomy looks elegant on paper, in reality we created a black box. It did what it wanted, and sometimes it completely ignored us. Let's see some examples. Sometimes it refused to answer in Greek, even though we explicitly asked it to. And that randomness was the worst part, because it meant that we didn't have something wrong in our code, just the result was not deterministic at all. Some other times, it decided to drop important metadata, like posters and ratings, especially in Greek language. Do you see any bias here? It even returned false negatives. Valid results were completely ignored. And occasionally, it restarted mid-process, doubling execution time. Did we try to add checks? Yes, we did. But if we need dozens of checks just to keep the agent stable, maybe it's time for a more deterministic flow. Hold that thought. Here is what this whole behavior cost us. 20% of all Greek queries returned incorrect results. The response time was about 30 to 40 seconds, which is faster than manual search, but still unacceptable for a user in an app. It also did 4 times more LLM calls than needed, which increased latency and cost. And 9% of all responses had missing data. And for developers, well, we had little to no control on the process. The pipeline was really unmaintainable, meaning that if we needed to extend it and add a new feature, it would be nearly impossible to do it. And, of course, it was extremely difficult to debug and understand why it took a decision and how.
And for the users, it wasn't ideal either. The chat-like interface pushed the heavy work onto them. They had to communicate their needs and make the system understand. Also, we made them vulnerable to say personal feelings to an LLM, which raised privacy concerns. The process was slower than we would like it to be because a single conversation was taking time to come to a conclusion. We didn't remove successfully fatigue, and the results were too deterministic, lacking variety and discovery.
So, great lessons for our proof of concept. Let's see how we improve it. we did improvements on both the front end and the back end. At the back end, we replaced the autonomous AI agent with LangGraph workflows, which gave us control, deterministic flow, a unified state, and debuggability. We also used caching to static data and recent queries, and also used a re-ranking algorithm for more diverse yet high-quality results. This means that if I query the same thing twice, most probably I will get different result, which is great if you have a database with thousands of movies and series. At the front end, we replaced the chat-like interface with small, emotionally backed chips that are easy to pick and, of course, privacy-friendly. So no more talking about your deepest feelings with a robot. Now let's see how the current architecture works in practice. This entire stack is built with Python and open source tools. At the center of the operation is a fast API backend. This is the main server that handles all the requests coming in from the front end. As soon as the backend receives the request, it kicks off a sequence of modular, orchestrated independent nodes orchestrated using LangGraph. LangGraph gives us real control. It replaces a fragile sequence of calls with a stateful graph. That means safer retries and stronger error recovery. If the LLM call fails, the graph state allows for instant retries without having to rerun the whole search again. Inside this workflow, we rely on LangChain to handle two main phases: discovery and enrichment. For discovery, we leverage the multimodal capabilities of the Gemini model to convert the user's vibe into a vector. This vector turns the emotional input into a numerical representation, something we can actually compare to our content. This vector then is passed to Qdrant to perform a semantic similarity search. Then Qdrant returns the results, the movies, that sit near that vibe in the embedding space, meaning they feel emotionally similar. After that, we re-rank the results. Here is where we make sure that the results are not just accurate, but also diverse, so you don't get the same popular movies over and over again. For enrichment, we pull the rest of the metadata from a traditional MongoDB. Then we call the LLM again to generate that short explanations. All of this process runs asynchronously. At the beginning, the front end receives a 202 status response from the backend and keeps polling for updates until the final results are ready. Once everything is ready, the front end picks up the results on the next polling cycle. And just like that, the user sees their recommendations. All of this that we saw before replaced our original monolithic agent with a modular orchestrated system that's faster, easy to run, and easier to observe and improve.
Now, let's take a look at the emotional journey of a user in the current system. They start off motivated. There is a small dip because they need to set their preferences since the system starts with their input. But after seeing movies that resonate and match the vibe, the motivation lifts again. Overall, the experience stays positive and emotionally steady. That's what intentional streaming is all about, putting users in control, not the algorithm. Now that we walked you through how we build it, let's see how it works.
Let's imagine that our user wants to see a movie and it's in an adventurous mood. The first step is to open Movie Groovy and click Start Here. At the top, they will pick movies, and then below, Adventurous from the Vibe chips. Here you can pick up to 2 options. We keep it that way to reduce decision fatigue while still maintaining the query specificness. Then we click Next, pick story style.
This step allows you to pick a genre, but it's totally optional. You can skip it if you are open to surprises, or select an option to narrow things down. Then click Next to pick platforms.
Here you pick the platforms you have access to. This step is very important. It filters out everything that isn't available on your selected services. So no more guessing if something is actually streamable in your country. When we are ready, we click Done, show me the pics.
And just like that, in 3 seconds, you get up to 10 recommendations. Each one comes with the title, the release year, where it's streamed, user rating, and of course, a short description why we're suggesting it.
Easy, right? Well, let's see the moments that shaped the whole experience.
People don't want to give you their data even before know who you are. Especially with new AI tools, they want to try it, and if it works, they can sign up. That's why we don't require a login at all. You can try instantly Movie Groovy, and if you like it, you can sign up for unlimited use.
We didn't trust the LLMs to do the searching. They're actually outdated and not reliable for content discovery. Instead, we used semantic similarity search on carefully selected movies and series. And we combined it with traditional filtering and smart reordering. All this gave us balance of emotional relevance and control, achieving precision without predictability.
After all the improvements, the whole journey from vibe to recommendations, it happens effortlessly, right as you sit back at your couch, fast enough to feel instant, slow enough to feel thoughtful.
And a big surprise was that users cared more about why a movie fits their vibe rather than it was a perfect match or not. By making the system transparent, make it feel human. And explainability builds trust.
We wanted to make people feel seen even when things didn't go well. So when we cannot find an exact match, we use the language model to generate customized microcopy. It's not that type of personalization that feels generic or forced. It's something more gentle and thoughtful. Those little details that make a big difference.
So what did we achieve overall? The responses come back now in just 3 seconds. We managed to lower the costs and make far fewer calls to the LLM model, which help us keep things lean and fast. We also have the system finally stable. It means that it works from start to finish. That it works from start to finish without surprises. It's also fully debuggable and extainable, which means that we can keep improving it without breaking things. And finally, we have full control.
To sum it up, what makes Movie Groovy different? Typical recommenders, look at your history. We start from something simpler and more human. What is your mood right now? And instead of trying to predict your next move, we focus on self-expression and we build the results around it. While most systems act like black boxes, We provide explainable choices, and you are able to understand why we suggest a movie that matches a specific vibe.
Before we close, I want to share what's next for Movie Groovy. First, we are planning to expanding it to even more countries, so more people can find movies that match their vibe in their own language at the platforms they use. We are also working on adding even more platforms than the ones we have right now, so our current users can discover even more content. And finally, we are adding a new feature I'm super excited about, the hidden gems. These are lesser-known titles that match your vibe, even though they are not trending or mainstream. And finally, if you want to try Movie Groovy, please scan the QR code on your screen. It's free. And if you have questions, comments, feedback, or ideas, please reach to us during the conference or send us an email. We'll be happy to hear from you. We hope this journey inspires you to create applications that not only work, but feel right. Thank you.
Thank you.